and he couldn't hear me. So he was wondering if anybody could hear me, but you guys are all with me, and we'll just keep going. As I was saying, some questions from last day. There's probably a few. Can you be specific as to the page? Because I gave you some extra practice stuff to do as well. Maybe the lesson, if it's from the learning guide, just so we're all clear on what I'm going through, and maybe I can just go through it a little bit more efficiently. That would be great. So far I have got one question. Just page 6, number 3. Is that it? One person had one question about all of this factoring stuff. That frightens me just a little bit. Oh, good. A few other people typing in. Perfect. Page 10, C and D. I assume that's from the learning guide, Bria. If you can let me know on that one. And just give you a second or two. A few more people typing. Okay, thanks, Bria. Page 6, number 3, and then 10, C and D, all of the learning guide for now. And perfect. Yeah, for sure. I'll go through some of those more challenging factoring questions. Let's start with page 6, number 3. Maybe I can jog your memory as to 7, 6. This is going way back. What multiplication question do the tiles below represent? Okay. So this is an algebra tile type question, and it's just asking what is the multiplication question, I suppose. So I look up at the top here, I have an x, I have another x, and then I have, so there's an x, and then 1, 2, 3, 4. So that top looks like 2x plus 4. And down here I have negative x's, so negative x, I have 2 of those, so negative 2x plus 1. So my multiplication question would be 2x plus 4 times negative 2x plus 1. And then we have our answer here. We might as well just look at what this is. This is negative x squared, negative x squared, negative x squared, negative x squared. And then I have a positive x. I have a positive x. This is a negative x, negative x. So I could go through all those like that. It looks like I have negative 4x squared. I don't know if the answer has the actual solution or not. I have negative x, 1, 2, 3, 4, 5, 6, 7, 8. So I have negative 8 x's, and then I have positive 2 x's, and then I have positive 4. So just combine my like terms in the middle. Negative 8 plus 2 is going to give me negative 6x plus 4. Hopefully I did that right. My algebra tile skills are a bit rusty. Here we go. So that was the first one. The second one, page 10, C and D. I'm thinking this stuff is factoring. 10, C and D. I think I did this a couple days ago. Page 10, C and D. There's only one C and D, unless it's factoring simple trinomials talking about, Bria. If we're looking at these guys, maybe you can just help me out there. Let me know if you actually want the ones that I've already done, or if you want the ones from down below, factoring simple trinomials. Maybe we'll just look at C again, because sharpen our skills. If I look at this, I'm asked to factor it, looking at letter C here. I asked myself, is there anything common between the two terms? So I guess the important thing here is for me to recognize that I have two terms. And in order to figure out how I have two terms, I need to see, is there multiplication, division, addition, or subtraction? So if I look right in the middle, I see that I have some subtraction. So I have one term here and one term here, and they're separated by a negative sign. So I have my two terms. Is there anything common between these two terms? So I say, well, I only have a 4x here, I don't have any x's here, but this 4x is being multiplied by everything in here, but I'm not expanding, I'm factoring. So I don't want to be multiplying, because that's the opposite of factoring. So what's common? Just at a glance, I see I have a 3x minus 1, and I have a 3x minus 1. So that is common to both of these two terms. So what I'm going to do is I'm going to factor it out. I'm going to pull it out. There we go. Now I'm going to have two things left over. What's left in my first term here, after I take out this 3x minus 1, all I have left is a 4x. So I'm going to drop that 4x down. And in my second term here, I have a subtraction sign. Once I get rid of this 3x minus 1, it's gone. What's left? Well, I don't have anything here. It's just blank. So what do I know is out front here, but I don't write? Well, there's always a 1 there. So I put a 1 back in. And that's that. That's done. If you want to think about it in terms of a multiplication type question, we can always check this. I have 3x minus 1. And then 4x minus 1. I'm going to multiply this whole 3x minus 1 times the 4x, and then this whole thing by the minus 1. And I'm not even going to actually multiply, but I'm just going to rewrite it. So I'm going to go 4x from here times the 3x minus 1. And then I'm going to have this negative 1 times 3x minus 1. Is that what I started with here? Are these two things the same? Yep. Normally I would expand this out, but for this question, I'm not going to do that. So that's it. This is the answer right here, 3x minus 1 times 4x minus 1. Basically, it's just pulling that 3x minus 1 out. Letter D is almost identical. I've already done it, so I'm not going to do it a second time. I think I did that last day or 2 days ago, so the video exists already for that guy. What's next? Mine's from the learning guide, got that. Any of the AC questions, maybe one from lesson 6, number 2. So this is the lesson 6 extra practice. Hopefully you guys had a chance to look at a few of these. I think I asked you to go over number 2. Let's just, right here. So number 2 at the very least. If you want to do more than that, go ahead, but number 2 is really important. So here we go. Number 2, extra practice. I guess I'll just start with A, because that's good a spot as any. 4x squared minus 14x minus 30. All right. Is there anything common to these three terms? Can I pull anything out of these three terms? So normally I would say this is ax squared minus bx minus c. I take my a and c, multiply them together. But if I can factor out something that gets rid of this 4 in front of this term, then I don't have to do the AC method. I can just do the regular method. So what's common between 4, 14, and 30? Does 4 go into 14? No. But each of these things goes, I can pull a 2 out of each of them, so I'm going to do that. I'm going to say, okay, I'm going to factor out a 2. So if I have 4x squared and I divide it by 2, what's left? Well, I have 2x squared. And then negative 14x divided by 2 is going to give me 7x. And 30 divided by 2 is going to give me 15. So all I've done is factored out a 2. And I can check to make sure I did this all right. If I multiplied it back out and ended up with the same thing I started with, then I'm good. So 2 times 2 is 4. 2 times 7 is 14, and 2 times 15 gives me the 30. So I'm thinking I factor that 2 out properly. Now, this is a factoring question. I look in front of my x squared term and I see that I have a number here. I have this 2. So I have to do what I call the AC method. So I'm going to take my a, which is a 2, and the c, which is a negative 15. I'm going to multiply those together and it gives me negative 30. All right. So I have negative 30 is my multiply to number. So I can write that down, multiply to negative 30, and then add to my middle term, in this case, is negative 7. So I need numbers that multiply to 30, negative, and add to 7, negative. 30 is going to be something like, I don't know, 30 times 1. That's not going to add to 7, but it'll multiply it to negative 30. How about 15 times 2? No, that's not going to give me 7. 30 divided by 5 is 6. Is that going to work? No. What are some other factors of 30? How about 3 and 10? So if I had negative 10 and positive 3, that gives me negative 30. And if I take these two factors and I add them, negative 10 plus 3 is negative 7. So I'm happy with that. Those are the factors I was looking for. So what I'm going to do is I'm going to take everything from the equation here and just drop it on down. So I have 2x squared. I'm going to take this 7x and I'm going to split it into 2 terms. And the 2 terms are 10 and 3. So I have negative 10x plus 3x. And then I'll just tag on the minus 15 in the end. Why did I pick 10 and 3? Those were the ones that multiplied to 30 and added to negative 7. So this 2 is just going to drop down. At this point, I want to kind of separate my question into 2 parts. You don't have to draw this line in. If you can just think about separating it into 2 parts, that's fine. Sometimes it just helps me think about it a little bit. So maybe I'm going to change this bracket out front to a square bracket now, because I'm going to have some other brackets inside. That just might make it a little bit easier to follow. Looking at anything common between my 2 terms here, so 2x squared minus 10x. What's common there? Well, it looks like a 2 and an x is common. That leaves an x and a minus 5. Whatever I have in this bracket, I have to have over here as well, else this whole factoring thing doesn't work out very well. So again, looking between these 2 terms now, what's common there? Well, I see I have 3 and a 15, so I'm thinking a 3 is probably common, positive 3. Anything else? No. All right, so I have the 2 still. That's not changing. Just coming along for the ride. And then I'm going to say, okay, what's common between these things now? Well, this one has an x minus 5, and this one has an x minus 5. And they'll always work out this way. So they always have to have that same bracket on both sides. So if I pull an x minus 5 out of this first half here, what's left? Well, I have a 2x. So I'm going to drop that down here, 2x. And if I pull an x minus 5 out of the second half, what's left? I have a positive 3. And that is the answer. So I just put square brackets and round brackets so I didn't get mixed up with my brackets. If you wanted to leave those as round brackets, that would have been fine. So the questions are a lot of work, I guess, but it's the same process, the same set of steps over and over again. You're doing the exact same thing every time. So I guess just a matter of kind of wrapping your head around these steps that we're doing. You can do maybe one more and then move on. Any letter here that's looking interesting to anyone? The fraction ones at the end, these are going to be a little bit messy to deal with, but not impossible. Maybe the letter C, because there's this y squared term hanging on the end here. Let's look at C. I'll just maybe do it down below here. This is letter C. 24x squared minus 28xy plus 8y squared. All right, first step of any factoring question is any common factors. What do all of these things share? 24, 28, and 8. I have x and x, but no x in the last term, so that doesn't work. So what's the largest number that's common to 24, 28, and 8? I'm thinking it's probably going to be a 4. (28) divided by 4, what's that going to leave us? A 7. All right, so I'm going to pull out a 4 and see what happens. So I have 4. Maybe I'll do a square bracket here so I don't get confused. All right, 24 divided by 4 is going to be 6x squared. 28 divided by 4 is going to be 7. And 8 divided by 4 is going to be 2. And then if I go 4 times 6, I get 24. 4 times 7 is 28. And 4 times 2 is 8. So I'm thinking that's good. There's nothing else common between my 3 terms. So I'm going to go ahead and say, is there a number in front of my x squared term? And in this case, I have a 6 here. So because it's not 1, I have to do the AC method. And the AC method will work for all of these questions. So if you want to do the AC method every time, it'll work. So the A in this case is 6. The C is 2, which gives me 12. So I need numbers that multiply to 12. And then add to my middle term, which in this case is -7. All right, so factors of 12, 6 and 2, 4 and 3. So I'm going to have -4 times -3 gives me positive 12. 2 negatives gives me a positive. And -4 plus -3 gives me -7. So -4 and -3 are going to be my factors. So I'm going to drop everything down. 4, 6x squared. I'm going to break my middle term up into 2 terms, and then I'm going to add on this 2y squared on the end. So I picked the 2 factors, -4 and -3. So -4xy, -3xy. That's what I'm breaking it into. At this point, I want to think of these as 2 separate halves. So the 4, my square bracket, just gets dropped down. What's common between my first 2 terms? Looks like a 2 and possibly an x. So I'm going to pull out a 2 and an x. It's going to leave me with a 3x minus 2y. and I have to have a 3x minus 2y over here as well. So I'm going to say, okay, what's common between these two terms over on this side now? Keeping in mind that I have to end up with a 3x minus 2y. So I look and I see I had a negative 3 here and a positive 2 here, but now I have a negative 2 and a positive 3. So my sign is flipped, so I need to, at the very least, pull out a negative to make my signs flip back to how they were up above. What else is common? Well, I have an x, but no x in the second term. I have a y and then a y squared, so I can pull out a y. Is there anything else that I can pull out that's common? No. If I multiply the y through, it changes it to a negative, and I get the xy and the y squared. So I'm happy with that. What's common? This 3x minus 2y, 3x minus 2y. So I'm going to pull it out. 3x minus 2y. What's left? 2x. What's left here? Minus y. And there we have it. So the more of these you do, the faster you're going to get, the more it's going to make sense. And if you're just jumping into these difficult ones with the number in front of the squared term, then they can get really difficult right from the get-go. So you might want to start with the previous simpler trinomials and then kind of work from there. I just want to go through lesson 7, which is a really quick one. And then if you guys have any other questions, I can go back and do some more of these types of questions for you guys. So the lesson 7 is called Factoring a Difference of Squares. And the actual factoring of these is really easy. The hard thing is recognizing when you have one. And there's a couple things that are a little bit different with these that you'll kind of notice right away. So let's just go through this. A special type of polynomial we will be dealing with is called a difference of squares. It's a binomial. Remember, binomial means two terms of the form a squared minus b squared, where a and b can really just be anything as long as they're both squared. So we can think of it as a trinomial with a middle term of 0. So instead of writing a trinomial, I guess we could write it a squared minus b squared. We would write it as a squared plus 0ab minus b squared. This middle term is 0. We can just write it like this. We don't need to write it in there. All right, so let's look at some examples. These ones are pretty straightforward. If you want to think of this as 81m squared plus 0m minus 49, you could. But there's a nice little trick that we can do to make these questions work out nicely for us. So in order to factor this, what we're going to do is we're going to first recognize that we have a difference of squares. So the difference means subtraction. So first things first, do we have subtraction? I would say, yep, there's a minus sign in the middle, so we have subtraction. The second part of this is squares. So when we say squares, what we really mean is perfect squares. Do we have perfect squares for both terms? Is 81 a perfect square? Yes. Is m squared a perfect square? Yes. Is 49 a perfect square? Yes. So our terms are perfect squares. It's kind of gotten a bit messy. So in order to factor a difference of squares, all you need to do is take the square root of the first term and take the square root of the second term. We'll just leave the little minus sign out. So the square root of 81 is 9. The square root of m squared is m, so I have 9m. And then the square root of 49 is 7. So this is why these are so easy to factor. Because I just write whatever I have taken the square root of, I write it twice, and one of them is going to be 9m plus 7, and one is going to be 9m minus 7. Maybe we should do just a quick check to make sure Mr. Borden hasn't lost his marbles. And that, in fact, works. So 9m plus 7, 9m minus 7. 9 times 9 is 81. M times m is m squared. So I'm foiling. I'm going to take the 9 times the 7. It's going to give me negative 63m plus 63m, my inside. And then 7 and 7 is 49. So you look in the middle here, and these two terms cancel each other out. So I'm just left with 81m squared. Oh, sorry, that's minus 49. Minus 49. And that is what I started with. So I'm done. Could it be any easier? I guess it could. But in terms of grade 10 math, when you get a difference of squares question on your test or provincial exam, you just say, thank you, math gods, for providing me with an easy mark. So let's do the next one. Do I have a difference? Negative sign in the middle. Yes. Check. Do I have perfect squares? Is 25 a perfect square? Yes. Is 36 a perfect square? Yes. Is x squared a perfect square? Yes. All right. I'm confident that you guys could probably do this question right now. Remember, one of them is going to be plus and one is going to be minus. So, what is the square root of each of my terms? Square root of 25, square root of 36. Square root of 25 is 5, square root of 36 is 6, and then I have that x. So I have 5 plus 6x and 5 minus 6x. That's it. You're done. Easy peasy lemon squeezy. Look at the next one. Do I have a difference of squares? For number 3 here, is 5 a perfect square? No. I do have the difference, which is a good thing. And then this is not a perfect square either. Oh no. What do I do? Anytime I have a question that asks me to factor, what is the first thing I should always do with a factoring question? Before, try to determine what I need to do, if there's a number in front of the A, anything like that. What's the very first step I should do with any factoring question? Let's see anybody typing feverishly. We need to look for common factors. All right, so what is common in all of these terms? I have x to the 4th and y to the 4th, so I can't do anything with those. I have 5 and 80. What's common between a 5 and an 80? I could probably pull out a 5, which is going to leave me with x to the power of 4, and 80 divided by 5 is going to be 16 y to the power of 4. So now we're just going to ignore the 5 out front. We're just going to drop it down. We ask ourselves, do we have a difference of squares? We definitely have the difference, so that's good. what's the square root of x to the 4? And what's the square root of y to the 4? Those are both perfect squares, just a matter of remembering what the square root of these things is. So when I have a difference of squares, I take the square root of the first, I take the square root of the second, and I go from there. So I'm just going to drop the 5 down. I'm going to write 2 brackets. One of them is going to be plus, one's going to be minus. Square root of x to the 4th is going to be x squared. The square root of 16 is 4, and the square root of y to the 4th is going to be y squared. So I just rewrite my terms, x squared, 4y squared, and I am done. Kinda. Can anyone see what happens here when I think I'm done factoring? What's the problem I'm running into here now? On the question, right here, this guy. Then I have another difference of squares. All right, so we have to just do it one more step. And I apologize, my chat wasn't scrolling properly, so I missed a few of those questions, but I will get to them. I'm just kind of catching up. So I'm going to bring the 5. I'm going to bring this x squared plus 4y squared, which is not a difference of squares, it's an addition of squares. And then I'm going to have to do one more step. So I'm going to have to take the square root of x squared and the square root of this guy. So I'm going to write 2 more brackets. One of them is going to be plus, one's going to be minus. Square root of x squared is going to be x, so I'm going to write it in, x and x. And square root of 4 is 2, and square root of y is y squared. So then, once I get here, I'm done. And you'd be surprised how many times that happens, because these questions are all set up to work out so nicely. You'll get to what you believe is the end of a question, and then there'll be another difference of squares. It's not going to happen all of the time, but it's important that you recognize once you've factored something, is there anything left for you to factor? So let's go to the next page, and then I'll give you an example of an addition of squares and why it doesn't work like these difference of squares does. You don't get why I did that, Taylor. Sorry. The question asked me to factor, and when I'm factoring, I'm saying, okay, I need to start with some multiplication, and then, you know, if I expand it all out, I get to the end. So we have expanding is multiplying, and then factoring is working backwards to figure out what we started with. So if I started with this guy right here, and then I multiplied these two things together, so this bracket by this bracket, I FOILed it, I would get to the next level here. I would end up at this step. And then if I multiplied this bracket by this bracket, that would take me to here. And then if I multiplied my 5 through the brackets, that would take me to there, the first step. So when we're asked to factor, instead of going up, it's the opposite of multiplying. We are going down. We are figuring out, essentially working backwards is kind of what factoring is all about. So there was still perfect squares here. This second bracket here had these perfect squares in it still. So I needed to go ahead and factor another step. And then once I get here, I can't factor anything anymore, so I'm done. There's just nothing I can do to factor that any further. It'd be kind of like if I asked you to multiply something, like 5 times 3 times 2, and you said, okay, 5 times 3 is 15 times 2. And I'd say, well, I asked you to multiply, why did you just multiply the first two terms? And then you'd say, I don't know. That's what we're doing, except instead of multiplying, remember we're working backwards. We're going kind of, if you want to think about it as going up, to figure out what you initially multiplied by. That's kind of where we end up. So it'd be kind of like doing a multiplication question and then only multiplying the first two numbers. Instead, we're factoring, and there's further things to be factored, so it's just not quite done yet. I know factoring isn't like a super obvious sort of thing that just comes to your mind, but I assure you after some practice, they do get a little bit easier. All right, 162 v's to the power of 4 minus 2w to the power of 4. Do I have a difference of squares? Well, the first thing I notice is the difference, so that's good. But 2 is not a perfect square. So I don't have any, I don't have a difference of squares here. So, all right, it's not a difference of squares. But I have a feeling that there's something common between my two terms here. So this one only has a 2 in it, so I'm going to see if I can pull a 2 out. And this one ends in a 2, so I know it's going to be divisible by 2. So I'm going to pull out a 2. 162 divided by 2 is going to give me 81 v to the power of 4 minus w to the power of 4. Alex, I'm not sure I know what you mean by the first one. Doesn't the first one still have squares in it? Like, yeah, I'm not sure which one you're referring to. I'll just keep plugging away at this, and if you can clarify, maybe I can help you answer that. All right, do I have a difference of squares now? Well, I have this 2 out front, so I'm going to leave that. Yes, I have a difference of squares because I have an 81, which is a perfect square. I have a v to the 4, which is going to be v squared is the square root of v to the 4, and w to the 4 is going to be w to the 2. So I'm going to write one of mine as plus, one is minus, and then I'm going to take the square root of both of these things. All right, square root of 81 is 9, and the square root of v to the 4 is v squared. So I'm going to write that in both brackets, 9v squared, 9v squared. And then my second term is just going to be w squared. So that is the square root of w to the 4th. All right, I end up here, and I think, okay, I've factored it, I've done my steps, I'm done. But no, I'm not done, because this guy here is another difference of squares. Now, this isn't going to happen as often as it's happening in the examples, but it's just something you need to be aware of. When you get to the end of a question, you need to say, is there anything else I can do to that? Can I factor it further? Is there anything common between those terms still that I can factor out? And in this case, it is. So 9v squared minus w squared. So I'm going to drop down my 2, I'm going to drop down my 9v squared plus w squared, and then I'm going to factor another difference of squares. I'm going to take the square root of this guy and that guy. One of them is going to be positive, one's going to be negative. So the square root of 9 is 3, and the square root of v squared is v. So I have 3v and 3v. And the square root of w squared is w. And now I am done. We'll look at this last example here, and then we will look at an addition of squares and why it doesn't work, because it's worth just pointing out. All right, last one here. Fractions. Ooh, strikes fear into the average math student. Not you guys, though. All right, x squared, is that a perfect square? Yep. Y squared? Yep. 36, yep. And 64, yep. So those are all perfect squares. And then do I have a difference in the middle? I do. So I have a difference of squares. Just like all of my difference of squares questions, I'm going to have two brackets. And I'm going to have one that's plus and one that's minus. At this point, I'm going to take the square root of my first term and the square root of my second term. So the square root of x squared is going to be x. The square root of 36 is going to be 6. So I get x over 6 and x over 6. I can do the same thing with my second term. Square root of y squared is going to be y, and the square root of 64 is going to be 8. Are there any other squares to deal with there? No. So that's it. You're done. That's just that easy. Nothing further you can do there. We have a little bit of time, and let's maybe, I didn't include an example like this, but let's just look at this. I'll just draw a little kind of box over here to separate this off. If you were asked to factor, and you had a question like 9 plus x squared, which is clearly not a difference of squares, but this is what Taylor and everybody else wants to know. If I'm asked to factor, so these are both perfect squares, I write it like this. Square root of 9 is 3, square root of x squared is x, so I have 3 and x. All right, so I think I'm done, right? I don't have any other perfect squares or anything in there, but let's check our solution here. So remember, the opposite of factoring is expanding. So I'm going to expand, and let's see what I end up with here. 3 times 3 is going to give me 9. I'm foiling here. 3 times x is negative 3x, and then positive 3x, and then positive x minus that is negative x squared. All right, I'm happy with that. I combine my like terms in the middle. They go away. There's 0, so I have 9 minus x squared, and I end up here. Is that what I started with? No, this is not what I started with. So when we are factoring a difference of squares, we must have subtraction. If we don't have a subtraction sign in the middle, we will not end up with what we needed. So it's just one of these things that doesn't work out. It's called a difference of squares. If it were called an addition of squares, then we could do it, but it's not. It must be a difference of squares. And it will not work out if you have two perfect squares separated by a plus sign. It just doesn't work out. You'll always end up with the wrong sign in the middle when you go to check it. So just one of these things. Difference of squares has to be a difference, and they have to both be perfect squares. Now, I did a bit differently, changing to multiplication by the reciprocal. Is that okay for number 5? So you just got rid of your denominators and then factored it. I don't see any problems with that. If you don't like dealing with fractions, you want to get rid of them, then that's fine. You'll end up with the same answer as long as you would just have to probably simplify at the end to get rid of something. So any which way you want to do these, you're good to go. If you want to do it that way, that's fine. There's nothing wrong with that. This obviously shouldn't be here. It's from the textbook. I forgot to take it out. The difference of squares with algebra tiles doesn't really work very well. This is why I hesitate to use algebra tiles. And I know I've spent most of my time just complaining about how bad algebra tiles are, but what can you do? They don't come up. But the way they're describing it here, the way I've included it here is, if you take like an A tile, like a regular A squared tile, you break it down a little bit further into this, adding these little pieces here and just calling this a B. Essentially what you're doing here is you have the distance along here would be A minus B, and then I have a plus B, and then I have another plus B here, which just gives me A plus B on the top, and then A minus B on the side. So in order to factor a difference of squares with algebra tiles, it essentially doesn't work. But if you want to think of representing an A as an A with this little minus B portion, it can work out. I don't know why you'd want to do that, but you could. So when you get into factoring with algebra tiles, when you're dealing with negatives, the algebra tiles don't work. And when you're dealing with the difference of squares, you have to use a little bit of, I don't even know what to call it. You got to kind of rig things up to your advantage. Would it come up on a provincial? I'm going to go with 99% no. But they can ask whatever. So there's a small fraction of a chance that a factoring of algebra tile type question could come up, but I've never seen one before. I don't want to say it never is going to happen, but I'd say there's such a small percentage of a chance of it happening that it's not even worth you learning. There's many, many more important things that you can learn to be successful on a provincial exam. So I could say with almost confidence that it won't come up, but I don't want to say it with certainty, because if it did, I would feel really bad. But I wouldn't worry about it. In fact, don't worry about it. If you can factor a trinomial with all positive terms using algebra tiles, that's great. I mean, that's all we can ask for. When the actual factoring using algebra tiles doesn't work out nicely, effectively, efficiently, then I can't expect you guys to do it that way when there's all these exceptions to the tiles and you have to break the tiles down and add these things to make different tiles. It just doesn't make any sense. So there you go. I was thinking you guys would have some more questions about the factoring trinomials stuff from last day. So this was a really short lesson. Maybe I'll just jump into the learning guide and we'll see. I think we should be good to go for everything in the learning guide.